What I said, POV, imagine, that's what I would like to do first. Imagine you are in Tomorrowland, Belgium, and you are enjoying, but then you see clouds moving. And one thing that comes in the mind of you that what if rain comes? Because you are fully dressed nicely and you are not prepared for rain. That's what exactly happened in 2022. I was there, so I know it. Uh, it was packed everywhere, and then suddenly rain appears. Everyone was worried, at least the talk that I see around me. But back in backstage, Armin van Buren, our own DJ, was very much relaxed because he knew it will not rain, and that is what we were waiting for his next session. How? Because he uses Buienradar, of course. And he checked the rain. He said, okay, now the rain starts, and he was very much relaxed. So he knew that it will not happen. Now some of you say, where is the proof? So I have the proof as well.
Thanks to the people from Buienradar. Look, we can see the rain. When my set starts, it's gone. So happy.
And this is not AI generated, by the way. This is before AI. So, and he is my very good friend, so that's why, no, he's not. But anyway, so the reason to show this, apart from all the reasons of showing off and everything, the main reason is the impact that we make on day-to-day life. This is just one example. People make plans using Buienradar, but there are millions, 10 million, 15 million. That was the number of users that we got in May. Now compare that with the population of Netherlands, which is 18 million. We do not expect babies and toddlers to worry about weather because they have so many other things to worry about. What it means, we get traffic from whole world, actually. It means Dutchies who are traveling around also spread about this magical app, they call it. I got a message, I think, a couple of months ago from somebody from Italy, and she said like she is very much impressed because of this magical app. So that's why magical is stuck in my mind. What does it mean? And this is very big achievement for a name which is Dutch, Buien means rain. I had very hard time pronouncing this because I am not from Netherlands. So when I came here, it was very hard to pronounce this, but now I think I can manage this. And that's what I'm going to talk about today, to show how we do the things, the good, the bad, the ugly, outmost terrifying, especially in tech, what we do. First thing first, who am I? I work as a solution architect. I'm Neel Bhatt. I work as a solution architect for Buienradar. So everything related to tech in Buienradar, I'm responsible. So you can blame me if it doesn't work, but it's fine. Apart from that, I work also as a chapter lead. So people do not know Buienradar is part of RTL. And I am also responsible for news and entertainment. So what I do, I work as a engineering manager, you can say that, for both of this product, mainly backend and frontend. So responsible for both of them. International speaker, I speak to different conferences, and these are all the companies I worked on. This is most important, what we are going to talk about, why Buienradar matters. The storm inside, turning the tide. I didn't try to make it poetic, but it sounds poetic when I say it. But we'll see first what are the problems that we had, what we did to make it better, how our architecture looks like, and 7 magical tips that you can use in your product that can help you to scale to millions of people. Why Buienradar matters? We know in the Netherlands, rain is not just a weather. Can somebody guess who is then? I will reveal. It's a culture, because this is very powerful image. A lady riding a bike with an umbrella and raincoat, even without it's raining, because she knew that it will rain, so she's fully prepared. And that's what we believe, that we want to make sure people use Buienradar as a personal weather assistant, looking at this before going out anywhere, making plans based on that. That's what our vision is. And that's what we make it believe. Now, this is a new UI, and this is a launch that we are doing actually tomorrow if everything goes fine. So I thought, okay, I'm in front mania. It's the best time to launch our new UI. So from tomorrow, if everything goes fine, by the way, I cannot promise, this is what at least weather per location page will look like in front end. So when you search for Dordrecht or Amsterdam, whatever, you will end up here. Our aim is to make it like a Google map, so that with a big screen, and from here you can see everything else. So this is, yeah, thank you. This is something that we are looking forward. Did I wait for Frontmania to launch this? No, of course we didn't wait for that. Does that mean we are behind the schedule? Yes, we are. But anyway, this is something we are going to launch tomorrow if it goes well. But Buienradar is the platform. It's not just a platform, but it's a part of culture. This is just to summarize what we have. So NMO is a media research that collects all the reach, like how and which brands are reaching to the maximum population of Netherlands. And they put this number every month. Last month, we were number one, at least for news and all other brands, except for ns.bol.com. What does it mean? We are reaching at least 43% of the Dutch population who are 6+. With 7 million users in account, and that changes every month. Sometimes it is 50%, sometimes 52%, but that is just to show the reach that we have in Netherlands. And from 2025, does anyone know DPG? What DPG is? I see some notes. From 2025, Buienradar or RTL is part of DPG. So what does it mean? As we speak, we are integrating with nu.nl, we are integrating with RD, we are going to integrate with Volkskrant. So in newspaper, in radio, everywhere you will see Buienradar. So imagine you don't like Buienradar, yeah, good luck to you, because you will see it everywhere, even in not just in Netherlands, but in Belgium as well. So that's something we are looking forward to, because this will give us the reach that we already have, and it will just increase to more. Let's just talk about some numbers. 5.8 billion views that we get annually. That's roughly 500 million monthly. The biggest day we had was 93.5 million views in one day, and 7.5 million unique users, which is almost half the Netherlands or even more. The part that I'm very much proud of is this is managed by a team of 7 developers. We are not team of 5 teams, 10 teams. No, we are just 7 of us. And that's something I'm very much proud of, and that's why I go to different conferences to talk about how we do the stuff. And I hope it will also inspire others to not reduce people, of course, but to see how we do the stuff. Now, to answer the question I raised, why Buienradar matters, it matters because nearly the whole country relies on Buienradar every single day. And when we fail, this happens. We go viral. So maybe this can get back to some of the bad memory from in your mind. But why it matters? Because if we fail, we get lots of feedback. So we cannot fail because this is on a country level. And that is what we saw as well. So that was something we were saying after 14 days, but still it helped us to go viral, and we were everywhere. Like, how can you do this, basically? The storm inside, it looks very good from outside, but we had problems, of course. But for that, I would like to enter you in a time machine. You are actually in a time machine. If you didn't notice, just look up, especially in the middle of the room. So just kidding. If I press a button to go in time machine, I made an error. So now we are back in a 650 BC. But if you are already here, just to give you when weather forecasting started. So Babylonians were the first one who were predicting weather based on clouds and halos, something like that. But this is very famous. Red sky at night, sailors delight. Red sky in the morning, sailors take warning. So they were just looking up. That's something we don't suggest, because otherwise nobody will use Buienradar. But this is how it started. And now if I turn little bit on the time machine again, somewhere in the era of 2015 to 2020, we had not so good days, because due to malfunction, no showers on Buienradar. Everything was failing, not every day, of course. On some days, people were also complaining about how slow the app was. Remind you, we were still getting millions of views at that time. It was not a problem, but the trust factor was losing at that time. And what was the reason? Monolith. We had a monolith, and whole app, sorry for that, whole app was having just 3 APIs, data, image, and subscription, and our code looked like that at that time. So everything was in one monolith. If it fails, it fails. Luckily, unfortunately, or fortunately, monolith died on 2019. So at least that's one thing to not worry about. But that was not the only problem. We had so many other problems as well. So we had scaling issue. Luckily, we had a very good platform where even our product owner can scale, let's say, from 7 a.m. to 11 p.m. because we know weather. We know that day after tomorrow it will be bad weather and there will be more traffic. So we can prepare in advance. But it was still from 7 a.m. to 11 p.m. Even if whole traffic is just until 7 p.m., we were throwing off all the money to Microsoft. So it was also wasting money. All this reason, observability issue, one wrong forecast, social media explodes. If upstream fails, we fail. So these were all the problems that we were facing until 2022, because 2022 when I joined Buienradar, so this is just to get some credits and claps. But yeah, this is until then. So what we did to turn this tide, basically. But before thinking about what we could do, let's talk about what we could do, but what we did not do. One thing that we can easily do is throwing more hardware. So if you just, okay, it doesn't work for 2 CPU, add more, 4, 6, 8. That is something, I hope it works like that, but it doesn't. Manual firefighting, we can put one person, okay, if there is a high traffic, go there and upscale manually. We could do that, but we didn't. We also could ignore human factor, so just work, we need to make it work. So anyhow, that also something we didn't do. We could also just blame upstream providers. I'll just remove this one because we still do actually. If something fails, we blame upstream providers like KNMI. We love KNMI, if you know, you know. But so if your team cannot scale, neither can your software. So what we needed to do was go back to the drawing board and create a plan. And that's what we did instead. So we decided that these are main things that we will focus on. Elasticity. Scaling is not just up, it should also come down. So if there's no traffic, it should also come down. Otherwise, you are just throwing off money. So elasticity in your software is very much important. Resilience. If something fails, again, upstream, we do not want everything to fail. Our system or APIs or our front end even should be resilient enough to handle any failures from upstream. Observability, we needed to see what's going wrong. So that is something, all of this point I will explain in the 7 tips that I will show. But this is what we did. And again, entering time machine because we need to see how it helped. 2nd July 2025, not just too much time ago, just few months ago. It was a rare phenomenon from KNMI. They issued 2 code orange. One for extreme heat and second for thunderstorms, which happens, but it was very rare. But back in backstage, our backend system was shining. And that's what we got our highest record so far in any of our historical plays. What we received on that day was what I already mentioned before, a few slides, 93.5 million views, 7 million. If we consider overlap between web and app, it was 7.5 million. Concurrent visit is something that in how much number of unique users are opening our app on span of 30 minutes, it was 1.6 million. So it is more like an Amsterdam plus Rotterdam, everyone at the same time opening the app, for example. The part that I'm very much proud of is how our backend, at least, system was handling this. Image API is the one that you see images when you open Buienradar. That was 30 milliseconds, even slower than the blink of your eye. Our graph API, location API, our forecast API, 200 milliseconds website. This is all we achieved from the part that we did throughout this before and after part. Again, 7 tips will help you how we did this. Now, if I go back to all the challenges that we had, we cross-mark all of them. We still have this one, by the way. It's very much hard to go away from this. And the reason to show why is this is what Buienradar app was before few days. We were showing 1 million rain on a specific day. Why? Because KNMI failed. So we blame KNMI always, but still, and if you don't know, KNMI is the Weather Institute in Netherlands, who is responsible for real radars in the Netherlands. So we rely on that data, but we do not just use KNMI data. We get data from Germany, we get data from UK, we get data from Belgium, France even. We combine them with satellite as well. And this is how your forecast or the rain or what you see. And that is, I'm proud at least that no other weather platform does that much combination in whole Netherlands. So how our architecture looks like, but before going to the architecture part, let's understand the products, because many people do not know what Buienradar already offers. Again, this is not a sales pitch, by the way, so don't think that. But what we do is we do nowcast, so what we show what is happening now, earthquake, lightning, everything, forecast and everything. But what people do not know that many, that there are different all other things that we also provide, like for example mosquito radar. You can see, I know not everyone uses that, but still. But terrace radar is something we are sometimes surprised to see how many people uses that. So these are all the things that we provide. But the part that I'm very much proud of is something that we recently built. We call it beach weather. So Netherlands had the problem, at least we got to know marine guards, from the marine guards, that every day there was one person dying by swimming in sea during summer. So what we did, we created a beach dashboard, we created our own algorithm based on the data, and we provided this to marine guards of Netherlands, and they are using it every day. What does it show? It shows if sea is dangerous to go or not, if there are rip current or not, if there are jellyfish, if there are mutants. So we provide and calculate this based on all the data that we receive. We have our own algorithm, and we provide this to marine guards. So it also saves life, literally. We also put it live on app, by the way, if somebody noticed, during summertime, so you can also see beach weather in app. And that is weather warning if something goes wrong, terribly wrong, KNMI issues, code orange or whatever, and we also show that in our app. So these are all the parts that we use. We use React in front end, or actually the redesign that we are working on, the part that I showed earlier, we are redesigning from .NET MVC to React. We are middle of that. We use C#.NET, Kubernetes, Grafana for observability, everything that's mentioned here, Prometheus for metrics, and Azure. So how our API architecture, anybody from backend, by the way, here? Oh shit, okay. I think it's wrong. So sorry for that if you don't like backend stuff, but our API looks like this. We want our API to look as dumb as possible. What does it do? It just gets from cache. If there is no data in cache, take from storage, update the cache, do it. We do not want our API to do any mathematical calculation, algorithm, anything. That should be done in backend, or the part that I will show now. So the part that you see in bottom is API, but part you see in up is all the magic happens, basically. We get data from satellite, we get data from all the different sources, as I mentioned. We have different cron jobs that run. Some of them runs every minute, some of them runs every 5 minutes. We name them as like this, sun service, rain, or something like that. We didn't put any fancy names on that. It goes in the queue. What we do generally, we source them, combine them, and we render. And then we render into different output. Some of them can be data, some of them can be weather maps, some of them can be normal images that you see. So when you go to Buienradar and when you say see the things moving, they are nothing but different images. It's more like a GIF, but not GIF. So we render different images every 5 minutes, and this is how you see like it's live streaming, basically. So from that, it goes to the storage, and from there, storage API picks it and go back, put it back to front end or apps. We also have management console from where our we also have a bunch of meteorologists, by the way, so they can also manipulate the weather in a good way. We cannot change weather, of course, but they can filter out some of the weather or cluster that radar creates. If you know the radar, what that radar does is it sends signals in the atmosphere, and whenever it collides with any precipitation, it can be rain, it can be snow, it can be anything, and then it comes back. From that, we calculate how far the rain is, how intense the rain or any precipitation is. But sometimes due to the curvature of the earth, so sorry for flat earth believers if there are any, but because of that, sometimes that signal goes and collides with a tree with rain, and then radar thinks that those are rain, but those are not rain. So from management console, we can filter out those faulty rain, and then we also have some of the algorithm to automatically do that, but we still gave it to the meteorologist to make it possible. So this is mainly our architecture looks like, but now some interesting part on tech side, at least 7 lessons from the journey that we have. We decided to have a solid foundation. We decided our backend to move to Kubernetes. I will explain why. We decided to create smart deployments to have specific strategy. I will mention why as well. We decided to focus more on observability, not just in backend, but also on front end, and we use Grafana for that. We decided to use or create a design to handle any failures. So we decided to have a system design that can make it possible. We decided to have a auto scaling, which is very aggressive. I will show how. We decided to prepare for failures, because even you do everything, what if, how you can make sure yourself ready for any impact. We decided to focus on latency, and at the end, what we are doing for innovation. I will also mention that. So first thing first, the co-creator of Kubernetes, Tim Hawkin, said Kubernetes is not just about managing containers, it's also about transforming how we build, deploy, and scale. Anybody uses Kubernetes or knows more anything about Kubernetes? Okay. Yeah, if you're in front end, you should know that. So sorry for being blunt, but I think it's also important that you know how deployment is done. Kubernetes is a way to deploy our applications. So what we did earlier, so from 2019, we started moving our monolith that I showed earlier into microservices. So now, instead of having big outage, we had now smaller outage at least, but with the microservices, it made it possible. Then we moved to Docker, and then later to Kubernetes. Now the question comes, why did we move to Kubernetes? First of all, for high availability, because if there is code orange, or if there is code rain, or if there is a high rain or anything, we do not want Buienradar to break. We do not want any user to feel or get wet because of Buienradar is not working. So we want our system to be as much high as possible. Of course, cost optimization, we were throwing all the money to Microsoft, so we wanted to stop that. If and only when required, we do auto scaling. So Kubernetes makes this possible. Faster deployments, by the way, we deploy anytime during the day. We do not have like a big bang release. And that's what also helps with the Kubernetes security and everything. So this is how our architecture of Kubernetes looks like. So we use GitOps and we use Argo CD. So Argo CD is in a way is a chef, and that follows the recipes that is given in GitOps. So it is in a way infrastructure as code. All the infrastructure related rules, we put it in GitOps. from there, Argo CD knows how and where to deploy the stuff. For example, if we mention our port to go from 3 to 30 based on bad weather, Argo CD makes it possible. So we don't need to do anything. If there is a high traffic, if there is a sudden spike, Argo CD knows what to do. It just puts the resource that is needed based on what we already provided in GitOps. And we have different environments. We have 2 environments for production. One is in west and one is in north for to make it possible. If one region goes down, we still have another one. Deploy strategically. There are 2 types of pet deployment. Those go wrong and those that go unnoticed. In 1800, there was or the bird is still there. There is a bird called canary, but in 1800 people were using it or misusing it. So this bird is something that gets affected basically, or affected because of carbon monoxide. So people were using this bird, were going into mines, and whenever this bird feels uncomfortable, it means there's carbon monoxide, so everyone goes out. We do something similar, but in our deployments. We do deployments based on number of things. For example, we just deploy 5% first, then we deploy 20%, then we deploy 50%. But let's say if something goes wrong in 20%, if there are a number of errors appearing, our system automatically rolls back. So we do not need to do anything. System just rolls back to previous version so that we do not deploy anything that is faulty in production. So it means there can be issues only because of the stuff which is already there, so because of memory leak or anything, but we do not deploy anything that is new, for example, because of canary release. That's not it, of course. Now imagine the part that I already mentioned. What if something is deployed last week and it still fails? Then we have SLO alerts. We define each of our system to be one objective. For example, we want our forecast to have 99.9 availability. When number of error occurs, this goes down. And whenever it goes down, we get called, basically. So our system automatically calls the people who are on call that, hey, something is going down, number of errors are increasing, watch out. So at least we do not let our user to tell us that, hey, this is not working. Our system at least tells us first, and we start working on it. Apart from that, we use feature flags. We do not have big bang release. The release I'm talking about tomorrow, it's not a big code that's going to production. It's just matter of switching. We will just switch from 1 to 2, whatever, basically tomorrow when we will put whole redesign live. If something goes wrong, we will switch back. So if you don't notice tomorrow, it means we failed and everything was back. But if you notice it stays for a couple of days, it means everything is going fine. And we use GitOps Argo CD, for example, automated deployments, because there is a saying, if something doesn't work in IT, first thing people do is restart. And our system does that automatically as well because of Kubernetes. Keep an eye on weather, because guessing what broke at 3 a.m. is never fun. Anybody who is on call, who gets called because something fails, oh wow, you people are so lucky. Okay, maybe everything is on backend, but no. So we use OpenTelemetry. There was a very nice talk, I think, a couple of talks before me from Elastic, who mentioned more about OpenTelemetry. We use OpenTelemetry. It's an open source framework. In a way, you can push all the code to this collector, and then you can plug to anything like Datadog, Elastic, Grafana. It doesn't matter, but it's more like a framework that we came up with in an IT world, and then that is commonly used in most of the companies as well. And this is how our observability looks like. So from Kubernetes pods, we put all of our logs to OpenTelemetry collector. From there, it goes to Grafana, which is open source, by the way. We do not pay for our observability, only for hosting. That's why we love Grafana. So if you don't know what is, I would suggest to research it. It's very nice tool. And also very low maintenance or any cost basically. So from there we can see logs, we can see metrics. So if it is logs, it goes to Loki. If it is metrics, it goes to Mimir, all those names from Grafana. And then in a Grafana UI, you can see everything. For example, this is the dashboard that we have for all of our system in our office. Sometimes we put it on our office as well. In this, we can see everything. So if something is failing, it turns red. And even our product owner can see, hey, this is not working, even though he doesn't know anything about tech. But that is something that we gave to business that look into this. Sometimes they just love watching this to see how, especially during bad weather, because you can see ports going up and down. It gives satisfaction. But this is one way to visualize everything. So how our latency is, how many requests we are getting, how many errors are there, and all the CPU and everything. So we notice this first. But this is not it. You can also deep dive into particular application. You can see more of your logs and everything. The one part that I like or love the most is Hotel.js. You can see everything that's happening in your front end. For example, FCP, anybody who knows about these things, Web Vitals basically. Some hands. But in a way, you can see how your this is a report card of your front end, basically, how front end is performing. And if you have front end which is exposed to millions of people, this is really important because you need to know how things are going. This is similar to if somebody is afraid of spider, you are fine as long as spider is in your eyes, but when spider goes away, you get more fear because you cannot see it. So it's better to make it visible. That's why observability is something very important. But this is not it. We also use Grafana for missing locations. So we had an issue. We are getting requests from different parts of the world, but we didn't know what was that. So we used Grafana to put it in one place. And then we also got requests from middle of sea. We have no idea who is using Buienradar from that region or that sea, basically, but this is how it is. Designed to handle failures. It's not whether a system will fail, it is when and how you recover. We use circuit breakers. Anybody knows about circuit breakers here? Yes, so in a way, circuit breaker is a system similar to in our house as well. It's more similar. If upstream is giving lot of errors, we do not want upstream to get bombarded with more. So it's really required that you stop that flow until upstream recovers and then you start the flow. So most of the time circuit is closed, but whenever there are errors, then we open the circuit, we let other service to recover. Meanwhile, in front end, we show that, hey, something is going wrong, we will come back. And when system upstream comes again, then it automatically comes back. We use retry, timeout, failover, self-healing Kubernetes ports, so something like restarting on its own. But we can visualize everything. Everything is not in theory. We can visualize everything in Grafana as well. So first thing is circuit breakers in action. Whenever something gets open, we get to know. We can also see retry, timeout, everything in Grafana. And that's something we really like. Auto-scaling. A well-designed system doesn't just scale under the pressure. It scales down when demand drops. And that was our main need. Traffic on Buienradar often increases. So as you can see, it is fine. Somewhere around 500 requests. It goes to 2,000. So more than 5 times in few hours. There was a football match going on, and during that, referee or the commentator just said, hey, look at Buienradar, or something like that. And almost whole nation went to Buienradar and open app exactly on that time. And this is what happened. So we went from 3 or 5 normal ports to 50 ports in the matter of few seconds. The part which I'm very much proud of, we went down in just few minutes. Because we do not want, and if we went up like that, it might cost us bankruptcy, I think, in few hours, not hours, days. But still the part that this is how aggressive our auto-scaling is. If you are interested to know more and how, you can reach out to me in our LinkedIn. I can share more, of course. 99% uptime is still 8 hours of downtime. So if you are very much proud that, hey, 99% is still fine, still there is downtime. And too bad customers remember them all. So that's what happens with Buienradar. Most of the time, whenever we do mess up, we go viral. And this is just something that you see in a UI, but in our feedback channel, we receive messages every second. So there is every second somebody's complaining about why, and same things. And when people do this, they are very angry. I don't know why, but sometimes they feel it like very much personally, like how Buienradar can break. So that's why we need to be prepared whenever something goes wrong. And we use PagerDuty for that. We have on-call rotation. Whenever something goes wrong, automated, first of all, from SLO, we get alerted. So we need to get this call. By the way, if you are on call, you cannot give excuse that why my phone was silent, because PagerDuty calls you. Even if you are on silent, it just calls you. So you need to get the call. If you cannot get the call, it goes to somebody else in a rotation. And from last week, we introduced, not we, but RTL Platform Engineering introduced something called Thanos. This is an AI app or bot. This is our first responder. So when something goes wrong, AI gets called. It does all the things that is needed. For example, this is just a testing basically. But if something is failing in API, it collects all the information and then it gives back to the first or second responder now, because first is AI, so that the person who is on call do not need to go deep into logs and check everything, because AI does that. And we have things like that. So all the things, for example, if we don't get data for rain for at least 10 minutes, we get notified as well. It might sound like we are getting calls almost every minute, but to be honest, we do not have that many incidents. We hardly get any calls because of these issues. And we only also focus on rain, because rain is our utmost priority. If something in photos is not working, we do not work immediately. We work next day. Or so for us, rain is the utmost priority, basically. And incident postmortem, no blaming. Sometimes we do, but anyway. So and learning is important, of course, and defining follow action. And this is how we do postmortems. One example. Akamai research said a 1 second delay in page load time can result in 7% reduction in conversion. So if your website is 1% or 1 second delayed in a page load, it means you are losing 7%. And this is not what I say, this is what research says basically. And things gets worse if it is 2 seconds, 3 seconds. So 1 second is still fine, but it means latency is very important. And this is how, for example, whenever traffic spikes, the part that I'm very much interested, this is live data, not live, but this is real data in bottom. So when we had high traffic before a couple of weeks, our latency was similar, even during high traffic. So it was 30 milliseconds, it remained flat. And that's what we do for that, we use cache. We use cache a lot. We use caching with proper TTL. It means this is how it works. Like, it gets filled, it goes down, it gets filled again, it goes down. So if you search for Amsterdam in Buienradar, first person who searches for Amsterdam saves the data in our cache. Second person who searches for Amsterdam gets the data from cache. So this is how our cache system works, and we do not call, or we just keep on saving based on the first person, basically. But this is not it. We do more. We do compression for payload. We do async processing. We do everything in backside. We follow DDD, so that's why our microservices are as small as possible. We use NoSQL. We use Elastic MongoDB. We do not have relational database. We have more like a NoSQL, so that everything is stored as one JSON, and that makes things fast, basically. Lastly, innovation. We do Shark Tank, let's call it, on a Buienradar level, of course. We try to plot rain on a 3D model, basically. It's not ready yet, of course, at one day, hopefully. But we use AI translation for weather report. Anybody who uses English Buienradar? Couple of hands. But if you use English version of Buienradar, we automatically translate the weather report, which is created by a meteorologist. They create the weather report in Dutch. We translate to English and French as well in different languages using AI automatically. We are working on personal weather assistant. So if hopefully things goes fine, and if I'm here next year, it might mean that you can even talk with Buienradar. So you can ask, is it fine to take umbrella tomorrow? So in a way, you can talk with Buienradar, and that's what we are working on, basically. And hopefully it will also be possible soon. If you search for Paris, the weather report that you see is not generated by meteorologists. It is generated using AI and data. So the weather report and everything also comes from there. I think it's repeated, but in a way, the same Thanos, as I mentioned, who is first responder, is also our PR reviewer, one of the PR reviewer. We do not rely fully on AI, of course, but Thanos also reviews our PR and also gives suggestions, something, and it works sometimes very nicely, something the human can miss, but AI doesn't miss. So that's really nice. This is just to summarize all the things that I already mentioned, 7 things. This is already last slide, so that's it. Questions? Yes.
Yes, you were talking about caching, but I can imagine that weather changes very quickly. How fast does the upstream data change, and how fast can you update it yourself?
5 minutes.
Every 5 minutes?
Rain, yes. Every 5 minutes we get new data for rain. And it depends, our caching is, for rain is 5 minutes, but for example, for photos or everything, it can be 1 day, or depending on how often that changes. For example, pollen index, we also show pollen index, but that doesn't change that often. So for that, we have 1 day caching or something like that. So it depends on which API it is, yes.
Yeah, I have a related question. Why decide to stop on 5 minutes? Is it a matter of finance or some technical?
5 minutes, sorry.
5 minutes of refreshing, is it related to some matter of financial matter or some technical one?
That's because of the upstream, because they also, the radar, by the way, that I already mentioned, is also checking every 5 minutes. So we have limitation on 5 minutes part. So I can understand that weather can change during that time, especially when you are looking into now. But I think as far as I understand, KNMI is also working on that to make it faster, basically. So, yes.
You also mentioned refreshing the images. Is that based on the map? Is the map based on images? Or is that a canvas or something?
So how Buienradar works, the one that you see in background image is static. So we have different background image, one for Netherlands, Belgium, Europe. What changes is the rain that you see. By the way, it's not cloud. Our product owner will not like it if you say it's cloud moving, because it's not cloud, it's rain moving, because clouds are too much. You cannot even see that. So rain, that things does is like an overlap on top of that image, and that's what we show every 5 minutes, basically. So, yeah. Yes.
You mentioned that you switched from Azure to Docker. Why did you do that? Because I think most of the developers, they do like migrate from Docker to Azure. That's my question.
Yeah, so we use Azure still. Docker is something that is deployed also on Azure. So Azure is more like a cloud provider that we use, but Docker is one of the virtual machine inside that Azure part. So we didn't move away from Azure. What we moved away was Azure App Service. We previously used App Service, which we moved to Kubernetes, basically. So, yeah. Yes.
I saw that canary rollout. Was that image accurate? Like 5%, and then after 30 seconds, it will jump to 20% rollout?
It depends on app to app. Some of the app we define like this. Some of the app, if something is crucial, we also check every we are more conscious, for example, 5%, and then wait for 1 minute or something,
Yeah.
and then roll out. Yeah.
Because it sounds very fast, like 30 seconds, and then could you already catch errors in those 30 seconds?
Yes, the errors that we see are most of the time during that. So if something fails, it's very fast. But you are right. In some of the cases, like we need to wait a little longer, of course. So it depends on which API we are putting live. So, yeah. Yes.
With your caching strategy, how come you still need to sometimes scale up your pods up to 50? What kind of service needs that type of scaling?
It's mainly because of number of requests. Because number of requests. So first of all, we also use Akamai. So if, for example, we have lots of requests from one particular origin, Akamai blocks it because we have very powerful DDoS, which I didn't mention, the security part, because we get DDoS attack lots of time. Some people just, every day we see some crawlers, basically. So we have defense system that comes above on top of API that blocks that. But it can not differentiate which is organic traffic and which is non-organic traffic. So if you are getting real traffic, it can already let in, basically. And in that case, we need to upscale because that's organic traffic. Even if we have caching of very powerful caching, basically, but still number of requests can overpass that. So that's why there are different rules that if we need, and it's not just one API, there are different API as well. So we are getting traffic from all of them because homepage is multiple APIs into that. So that's why. Any more questions? Yes.
Yeah, what do you think about microservice versus monolith? Because nowadays you also like read about people saying, yeah, microservice is like too much now or something. Like we need something in the middle, or what do you think about that?
I personally love microservices because with monolith we had issues. I know there are things like vertical slice architecture and you can still make it possible. But if I say why I like microservices, also because of the separation, basically DDD, the domain you can divide into specific part. With monolith it also helps, it doesn't help in terms of proper segregation. Even though we are just one team, we are just 7 developers, we still need to have proper segregation if you are working on a particular feature. Otherwise, it can create more conflicts, blah, blah, blah. So it's not just about platform engineering, but also in terms of development day to day. So
Yeah, but it can also really increase the complexity, right? And if like a lot of services have to talk to each other, there's like extra latency.
yeah, that's a good point, and that's what we are trying to resolve at this point as well. So we do not have thousands of microservices. What we created from one monolith is 15 different APIs. So we try to be very conscious that we do not create very small microservice because of the same reason as you mentioned. And that's why we are also conscious about making only what front end needs. So front end needs location, front end is forecast, front end is image, that's it. So we do not call API from API to API because that is a pain that we also, so yeah, I agree with you. And that's what we try to avoid. Okay. Then that's it. Yes.